Section 1.1 talks about real numbers. And there's this Venn diagram, a series of circles. The yellow box indicates real numbers. So anything inside this yellow box is a real number. We are not going to talk about non-real numbers or imaginary numbers right now. Imaginary numbers would not fit in here at all. For the real numbers, you can have natural numbers, integers, rational numbers, and irrational numbers. Natural numbers are often called the counting numbers. These are the numbers that you, like if you're counting on your hands, 1, 2, 3, 4, 5. Notice it does not include 0. 0 is not considered to be a natural number. Natural numbers are things that you can count on your hand. Integers are positive, negative, and 0, but notice that they are still no decimals. So integers are positive, negative, 0, no decimals. Okay, rational numbers are fractions and numbers that can be written as a decimal, but it's important to note that the decimals are either repeated with a pattern decimals or decimals that could be turned into a fraction. If you're familiar with the fraction features on your calculator, if you have a decimal showing, if you can change that into a fraction, it's considered a rational number. So this is fractions or decimals that can be turned into fractions. Irrational numbers are completely separate from these other three circles. Irrational numbers are decimals that are non-repeating. There's no pattern to them. They keep going forever and ever, and they can't be changed into a fraction. Some very common examples of irrational numbers are the square root of 2. If you do that in your calculator, it's some crazy decimal that keeps on going forever. And pi. Pi is 3.14159, and it keeps on going forever and ever. The interesting thing here, and I think you'll notice that I've got the number 3 circled in all three of these circles. The number 3 is considered to be a natural number, an integer, and a rational number because it can be written as the fraction 3/1. So if something is a natural number, it is also the other two. If something is an integer, like -2, -2 is also a rational number. 0 is an integer. It is also a rational number. If something is a rational number, it may not be the others, but I want you to think of this as a bullseye, and if it's in the inner circle, it's also going to be labeled with the things of the other circles. On the next example, we need to describe each number as A, natural, B, integer, C, rational, or D, irrational. And notice, if it's A, it's going to be A, B, and C. If it's B, it's going to be B and C. If it's just C, then it's just C. If it's just D, if it's irrational, then it's just going to be irrational. So these are going to be your answer choices. -5. -5 is a negative number. That makes it an integer, so it's going to be B. If it's B, it is also a rational number, C. 0. 0 doesn't exist in the natural numbers. It only exists in the integers, which means it is an integer and a rational, B and C. 5/4 is a fraction. I didn't mention this before, but ratio means fraction. So a rational number, ratio is in that word. It literally means a fraction number. 5/4 is a fraction, so it's a rational. It is a rational, not irrational. 3.14, because it doesn't have a ... because it doesn't continue, they're saying the number 3.14. They're not saying pi. The number 3.14, if you put that in your calculator, that can be changed into a fraction. If the decimal terminates like that, if it ends, it can be turned into a fraction. That is a rational number. Pi is irrational. 999,999,999. It looks crazy, but it's a positive number. If you had basically a billion, if you had a billion fingers, you could count to 999,999,999 on your fingers. So that is a natural number, which means it's natural, integer, and rational. Square root of 3, if you plug that into your calculator, it's a decimal that keeps on going forever and ever and ever, so that's irrational. Square root of 9, however, is 3 or negative 3, so I would call that an integer, which means it's also rational. And this is a math joke that a lot of math teachers like. I is the imaginary number, so I is not a real number, and pi is not a rational number, it is irrational. So the not real number is telling the irrational number to be rational, and it's telling it to be ha ha ha. Okay. Ordering real numbers. If you put the numbers on a number line, if A is to the left of B, then A is less than B. So in this picture, -3 is less than 2. Honestly, the way that you learned this in elementary school with the alligator eating the bigger number is really still the best way to think about this. Describe the relationship between each pair of numbers. 3 is less than 5. You could also write that 5 is greater than 3, but we don't like that version in math. Once you get to this level of math, you really want to put the smaller number less than the bigger number. It's just better. So on B, -1.9 is less than -1.09. If we want to put fractions in order, figuring out which one is bigger than the other, we need to write both fractions with the same denominator or write them in decimal form. And the easiest thing is probably going to be to write them in decimal form. So you may want to get a calculator out at this point. I'm going to pause my video. Okay, I just got out a calculator. So 9/16, 9 divided by 16 is 0.5625. 5/8 is 0.625. Which one is bigger? 0.625 is bigger. -7/3 and -5/2. We've got -2.33. 5/2 is 2.5, so -2.5. Now with negatives, this can be a little tricky, but remember, if here's 0, -2.5 is here, -2.33 comes before that. So -2.5 is actually smaller. -2.33 is bigger. With negatives, you want the one that is closer to 0. The one that's closer to 0 is the bigger one. 3 is bigger than -4. And on this one, again, with negatives, you want the number closer to 0. The number closer to 0 is bigger than the number farther from 0. The bar graph shows the profits for a company from 2008 through 2013. Compare the profit for 2008 with the profit for 2009. So 2008 is here, the profit is 42.1. In 2009, the profit is -15.2. And I believe it's in millions of dollars. So the company lost quite a bit of money. Anytime you compare, you can use subtraction if you want to. So 42.1 minus a -15.2, the company lost $57.3 million. But anything that you want to write there is totally fine. So compare the profit. In 2009, the company lost money. You can be a lot more specific if you want to. You can say the profit decreased by 57.3 million. You can say that they had negative profits, whereas in 2008 they had positive profits. Write a statement that summarizes the trend in the company's profits. Well, in 2009, looks like their profit crashed, and then they've been recovering since then. However you want to word that is totally fine with me. Just write some sort of statement. Show me that you are looking at this chart and realizing, hey, they were doing really well in 2008. 2009, I don't know if any of you know anything about 2008 to 2009, but it wasn't good for the economy between 2008 and 2009. So they lost a bunch of money, their profits were negative, and then from 2009 to 2013, they started regaining profits. For any real number, the distance between the number and 0 on a real number line is called the absolute value. We use these vertical bars to indicate absolute value. So -8 is 8 units away from 0, so the absolute value of -8 is 8. Absolute value just indicates distance from 0. That's why it turns everything positive. So in this example, the absolute value of -9 is 9. The absolute value of +9 is 9. So those are equal. I want you to take a moment and figure all of these out and then play the video again to check to see if you did it correctly. A couple things to note here. In D, you've got -4 on the left, and you've got negative absolute value of -4 on the right. -4 inside the absolute value bars is going to become +4, but then the negative will drop down, and that will end up being -4. Same thing in F. The absolute value of -2 is 2, but then you drop that negative down, and that ends up being -2. So check those answers. And your assignment begins on page 2 of the textbook. If you're doing this in Schoology, there is a PDF attached to the assignment that has all of the problems basically between number 2 and number 86 on that PDF. You just need to look carefully at which specific problems you need to do. Make sure you label your assignment 1.1 book assignment or section 1.1 assignment or whatever. And then I would also put these problems at the top of your page. Don't forget to put your name on the top of the page. And let me know if you have any questions.